Hello everyone, welcome to my video. So we'll be starting with calculus, and today I'm going to focus more on function in calculus. So the question now is that why does calculus exist and why do we have to study calculus? So watch this video to the end so that you'll be able to understand why you need to study calculus and what calculus solved. So let's start with this problem that mathematician asked. So the problem is, from the beginning, to determine the circumference of a circle is very difficult because circle is a curve, it's not a straight line, it cannot be determined. So someone come up with an idea that if we inscribe a polygon into a circle, the total length, or let me say the total perimeter of that polygon is not always up to the circle. So let's now keep increasing the number of sides of the polygon. We can notice that as we keep increasing the number of sides, the total length or the total perimeter of the polygon approaches the total perimeter of the circle, that is getting close to it. So that means that if we keep increasing it over time, we have to increase it to a particular number. So when you get to a particular number of sides, it's going to match the perimeter of circle, which we call the circumference. So what is now the number of the side we must divide the circle into for the perimeter of the polygon formed to give us exactly the perimeter of the circle? So the answer is there is no number. The number should be infinitely big. That is that the more we keep dividing it, the more it approaches the real value we want. So that is exactly what calculus helps us to solve. So normal mathematics failed because when we say infinite, what is the exact number that is infinite? That is what calculus helps us to solve. So alright, so in today's video, we'll be focusing on the introductory part of calculus, which is function. So when we talk about some function, that's a definition. But before I define it fully, I like to introduce us to some terminologies we use when we are describing function. So the first thing is a constant. So whenever you hear a constant is something that is not changing, irrespective of the when you change some other things, the thing will still remain what it is. Example is like 4. When you have 4 is a number. If you like, you should do anything to 4 will still remain 4 because 4 is a constant. So also pi is a constant because pi has a particular value, so that value does not change over time. There's nothing you can do to pi. If you like say x is equal to y, pi will still be equal to pi, it will not change. So if we say k is a constant, definitely k can be any number or anything that does not change. So that is what a constant is. So I can just say a constant is something that does not change. Alright, so we have another thing we call a variable. So what is a variable? A variable is direct opposite of constant. So a variable is something that is actually changing. So if I say x is a variable, what I mean is that x can be anything. It can be 1, it can be 2, it can be 3, it can be anything. So if I want to define a variable, I will say a variable is something that changes. So your temperature changes, so your temperature is a variable, but 4 is not a variable because 4 is 4, it does not change. Do you get? So also we have what we call a relation. And what does a relation does? A relation is just like a rope that tie to let me say that join two variable. So anything that join two variable, so let me say 2 or more variable together, or it can also contain a constant. So such thing is called a relation. Okay, so let me give you an example. When you say y is equal to x plus 1, this is telling you that this y is a variable. Y can be anything, y can change. This x2 is a variable, x2 can change. what is joining y and x together is called a variable, or sorry, is called a relation. So this is a relation. So if I can write it as y is equal to s plus 1, and I can also say y gives us s plus 1. What this means is that this x is the image, the input, and this y is the output. So whenever I put a particular value of x, I'm going to get a particular value for y. So this is input, this is output. So what is joining them together is called a relation. And now we have what we call function, which is our main goal. What is a function? A function is a special type of relation that when you put one input there, you will get one output. So this y is equal to s plus 1 is a function. Why is it a function? When I say x is equal to 1, my y will be equal to 1 plus 1, that is 2. Y cannot be anything so far aside from 2. So far my x is equal to 1. So this is called a function. It's also a relation. But when I have something like this, y is equal to plus or minus square root of x. So when I set my s to be 1, my y will be plus or minus square root of 1. Square root of 1 is 1. So that will give me plus or minus square root of 1, which is 1. So my y is equal to plus 1, and this same y is equal to minus 1. So this is not a function, it's a relation. This relation is joining two variables together, y and x. But because when I put a particular input, which is x there, I'm not just getting only one output, I'm getting two outputs. Once I get anything greater than one output, then it's no more a function, then it's a relation. So anything we call relation is generally something that joins two variables together, but function is a special type of relation that one input will always give one output. And we have what we call domain. That is the most important thing in this section. Moving to domain, what is the meaning of domain? The meaning of domain is that there are some functions that is not everything you can input. Like, let me give you an example. When you have y is equal to x all over x, in mathematics we will all say that y is equal to 1. Abi? That is what we all say. But this function has a domain. And what is the domain? A domain is this x is input. There is one value for the input, and once you input it, everything is going to crash like 0. If you now say that your x is equal to 0, that means y is equal to 0 over 0. And 0 all over 0 is not equal to 1. It is indeterminate. So if 0 all over 0 is indeterminate, that means that you can put every value in this function except 0. So far you put 0, this y is equal to 1 is going to hold again. So such value that you that would make this function to be undefined, when you remove that value from set of all inputs, then the remaining ones are called domain. So domain is all set of inputs that you can put into a function that will have an output. So that means that I can say domain is all possible inputs. Okay, let me say all possible inputs minus inputs that give no output. So if I was asked to find the domain of this function, y is equal to s over x, I would say this my domain is the set of all real number excluding 0. So that means that all real number is going to give an output, but once it's 0, it's going to give me indeterminate, which is not an output. So anything like that is called and every real number apart from the one that is giving no output is called domain. And if you want to write it mathematically, you say that S is equal to, or you say S is an element of real number. Real number is represented as R. You now put it in bracket that X is not equal to 0. That is, X can be anything, but X must not be equal to 0. So that is input. That is domain. Domain tells you the limit of input you can put for this function to be defined. So there is another thing we call the range. So when we say a range, we know that a domain is input, limit to input you can put, but range is now like there are some functions that they cannot just give an output. Let me give you an example. Let's assume we say y is equal to the absolute value of x plus 1. So that means that irrespective of value of x that you put, even if you put x is equal to minus 1, if you say minus, okay, let me say minus 2, if you say minus 2 plus 1 is going to give you absolute value of minus 1, and we all know that absolute value of negative number will still give you positive number. So this function will always give you positive number. That means that the range is the set of everything that you can have, the set of all outputs you can have. So set of all outputs I can have is that all my outputs will always be positive. That means that my range is set of all positive number. So if I want to write it, I can say my range is element. I can say my range. Okay, let me say it like this. For my range, I can say my y is greater than or equal to 0. That is that my y will always be positive. It can be 0 or anything greater than 0. It cannot be negative. Do you get? So other functions for domain and range. Okay, let's assume we have s is equal to s square. Let me say y is equal to s square minus 3 all over s minus 2. If you are asked to find the domain for this function, for all function, once the denominator is equal to 0, irrespective of value of numerator, once the denominator is 0, the answer is undefined. And how do you know? Let's assume that let's say any number. Let me pick b all over 0. So b can be any number. Let's say the answer is equal to c. So when I divide b divided by 0, I want to see the answer I'm going to get. If there is a value that is going to give me, so that means that if I cross multiply, this is c all over 1. So if I cross multiply, I can say b is c times 0, like b times 1 is c times 0. So c times 0 is 0. Do you get? So that means that if I put my c to be 1, so 1 times 0 will still give me 0. Any number I put will give me 0. That means that my b is c times 0, which will give me 0. So this is going to hold if my b is equal to 0. And we all know that 0, if my b is 0, that means it's 0 all over 0. So, and we all know 0 all over 0 is indeterminate. So with this now, these are proving that so far the denominator is 0. The only thing that can make it to be divided is when the numerator is also 0. And we know in mathematics that one itself is not even possible, because 0 over 0 is indeterminate. So in this case, once the denominator amounts to 0, that means that the graph does not exist here. That means there is no output for that. So since my denominator is s minus 2, so at a point where my denominator, which is s minus 2, is equal to 0, that means that at that point s is equal to 2. So once my s is equal to 2, irrespective of value I get as my numerator, so far my denominator is 0. That means that the function itself is undefined at that point. So I'll just, if I put 2 inside it, that will be s squared. That is 2 squared minus 3 all over my x is 2 minus 2. So 2 squared is 4. 4 minus 3, that is 1. 2 minus 2 is 0. Can you see 0 to 1 over 0, which is undefined? So if I want to write the domain, I will say domain of this function is that x is element of all real number where x is not equal to 2. That is telling me that it can be anything, but it cannot be 2. And if I want to find the range for this stuff, what I will do is that I want to know the value of y
that this x cannot produce. So the easiest way for me to do this is to, let me open another thing so you can understand. So I know my y is equal to x squared minus 3 all over x minus 1. Is to differentiate this function, like find the y dx and set the y dx to be 0. So to get your minimum and maximum point. So your minimum and maximum point is just giving your range, the minimum value you can get, the maximum value you can get. So that is going to give you the range. So if you say it has only minimum point, so anything below the minimum point cannot be range. Let's assume that you do it finish, your minimum point is 2. That means that anything below the 2 is out of the range. And if you say you get only maximum point, so that means any value above the maximum point is too big, like is the outside the range. That means you cannot get any value that is more bigger than the maximum point. That is the meaning. And if you have minimum and maximum points, function that have that function has given you the range, the smallest. So if you know the minimum point and the maximum point, so you can know the range. You know the range is like every number between the minimum and maximum. It cannot be less than the minimum and it cannot be greater than the maximum. So for this question, I can actually use differentiation method, but that will looking at this thing is something you can differentiate, but there's still some way you can do it algebraically without using differentiation, and that will be quite easier. So this is what you are going to do. So if I know that my domain is value of x that work for this engine, that is anything outside that will not work. So my range is value, the value I can get for my y. It's not all graph that is continuous. There are some graph that are like this. So if a graph is like this, that means that this graph, there is no value you can put for x. It cannot exceed this limit, and also there is no value you can put that will exceed this thing. There are some graphs like that, they will not be like this. So they will not come down more, and they will not come down more, and they will not go up more than the maximum. They will not come down more than the minimum. So such graph is what the range. They used to have range that is not all real number. It's different from this one that is a straight line that so far you have x, you always have y. That one does not have a range, or let me say the range is all real number. Okay, so for this case now, this is what I'm going to do. I'm just going to make my s solver formula so that it's range I'm looking for, but once I make s solver formula, it has now become like I'm looking for domain. Do you get? So I'll now make the s solver formula by this y is saying the same thing as y over 1, so I will cross multiply. So that will be y into bracket s minus 1 is equal to 1 times s squared minus 3. I want to make s solve formula. So y times s will give me xy, y times 1 will give me minus y. So 1 times s squared will give me s squared, then minus 3. So I want to make s solve formula. So literally I'm taking everything to this side. This is s squared. This sy will come to the other side, which turn to minus xy. This y will come to the other side, which turn to plus y. And this minus 3, this is equal to 0. Since I have taken everything on the left hand side, it's remaining 0. So I can say my s squared minus xy plus this y plus 3, I can group them together. Y minus 3 rather. So if I say this plus times y will still give me plus times minus will give me this minus back. So it's still the same thing I'm writing, it's equal to 0. But because of a reason, I'm going to change this question over to plus. Reason is because that to make it easier for us, if we have factorization, we're factorizing. So they will give us a question that it's easy for us to factorize. So what I want to prove is that I want to find the range for this question. So I'm changing this to plus to make it easier for us. Alright. So now if you have s squared minus 5x plus 6 is equal to 0, if you want to factorize, you can use quadratic formula, or you factorize by saying, if you want to use factorization almighty formula, quadratic formula, you say this is your b, this is your c, this is your coefficient of x square is your a. Same thing, I want to make x general formula. So the coefficient of x square is 1, coefficient of x here is minus y. So I can say my a is equal to 1, my b is equal to minus y, because this minus and y is the coefficient of this x. So and my c is the constant, which is y plus 3. So that means my x, I'm using almighty formula, is equal to plus or minus, minus a b, which is minus b is, my b is minus y, so minus b is minus y plus or minus b square. So b square is minus y square minus 4 minus 4ab, my a is 1, 4ac rather, my c is y plus 10. It's because of this square root, that is why I change this into plus, for it to be easy for us to work with. Alright, so it's equal to 2a, my a is 1, so minus as minus will give me plus, that will be y plus or minus square root of minus y square will give me y square, minus 4 times 1 will give me 4. So that 4 that I get, I will now use it to open the bracket. 4 times y will give me 4y, 4 times 12. Okay, so this one too is having minus, so minus times plus will now give me minus, so that will give me minus 12 all over 2a is equal to 2. So we all know that in a quadratic, this is the value, this is my x. So if my y is now my input, now that means that all I'm looking for value that I will put inside this equation that will make it undefined, that will not get any value of x. If I can get that, that is my range. Like that is something that is outside my range. Do you get? So with this, we all know that anything inside square root, for that thing to give us a real number, the thing must be positive. That is, every y square minus 4y minus 12 that I'm doing, it must be always be positive. If it is not positive, all this thing will not be divine. Do you get? So that means that I can say that y square minus 4y minus 12, which is inside this bracket, must always be positive, unless the whole function is going to affect, first going to affect the square root. So far it has affected the square, it's going to affect the whole function. We are going to become getting a complex number, which we don't want. So must be positive, and if something is positive, we will say that it is greater than or equal to 0. So any number that is greater than or equal to 0 will be positive. Minus 1 is less than 0 because it's negative. Do you get? 1 is positive because it's greater than 0. 0 does not have negative and positive, so that is why I say greater than or equal to 0. Alright, so I'm just going to factorize this. So factorizing this, that will give me y square minus 6y plus 2y minus 12. We all know how to factorize. So y is common, y minus 6 plus 2 is common, y minus 6 is equal to 0. So y plus 2 y plus 2 y minus 6 is my sub. So normal, if y plus 2 y minus 6 is equal to 0, I will say my y is equal to minus 2 and y is equal to 6. So because this one is greater than 0, you just need to know that the one that is bigger is the one that will take this sign, the one that is smaller is going to take the other sign. So it's just y is, because it's great, 6 is greater than minus 2, this is going to take that greater than sign. So y is greater than or equal to 6, and the second one will take the other side. So and y is less than or equal to minus 2. So that means that any value that is less than minus 2 will make this true. Let's test this. If we take y is less than minus 2, minus 3 is less than minus 2. So if I put minus 3 in this function, minus 3 square will give me 9. Minus 4 times minus 3, minus times minus will give me plus. So 4 times 3 is going to give me 12 minus 12. So 12 minus 12 will give me 0. So that will give me 9. We all know that 9 is greater than 0. That means that this thing I write is correct. If you test another number that is less than this, greater than 6, okay, a number that is greater than 6, let's pick like 7. So if I say 7 square will give me 49. Minus 4 times 7, 4 times 7 will give me 28. So that is 49 minus 28 minus 12. Let's see if the result we are going to get is going to be greater than 0. So minus 28 minus 12 will give me minus 40. Abi? Yeah, so if I say 49 minus 40, that means that 49 minus 40 will give me 9. 9 is actually greater than 0. That means that this stuff I write is correct. So that means that for me to get a real value, my y must always be greater than 6 and my y must always be less than 2. So my range will now be -2 is greater than or equal to range, and this same range is greater than or equal to -6. That is that this -2 is always greater than range. That is or I should say, yeah, okay, let me say it like this so that you will not be confused. Let me write it in normal notation. This notation itself is wrong, I'm sorry. So if y is greater than 6, greater than or equal to 6, and y, this same y is less than or equal to -2, so there is no value that can be greater than 6 and at the same time less than -2. Do you get? So that is why this one is wrong. So if you want to write it, you say y is greater than 6 abi. So that means that y is starting from 6 and is greater than, so it's going any number that is going in positive way, irrespective of how big that number is. So I can say y is from 6 to infinity, like this infinity that is going in positive way. So and also this same y can be equal to -2 or less than -2. So that means that it's starting from a very very less number to -2. Once it has reached -2, it will not work again. So I can say that -infinity, -2. So this and this we hold. So I will join it with union. So this is how we write it mathematically. So we now say -infinity is this, and then union 6 is less than infinity. So this and this, they are the same thing. It's telling you that y is less than -2, starting from the left hand side, from the highest left hand side number, and this union, the union is that and this, the meaning of union is and. So and is also, it can also be anything from 6 upward. That is the meaning of this. So that is just it. And also if you have function like y is equal to 1 over x, when you make s the sort of formula, that is 1 over y, you can still use that same approach. So when your y is equal to 0, when your y is equal to 0, there is no value for x, because when y is equal to 0, s will be undivided. That means that your range for this function s is equal to 1 over y is all real number. Or let me write it like this to be easy. I will say y is all real number except 0. I will now say y is not equal to 0. So this is my range for this function, and for this other function, this is the range. That is that it ranges from any number from negative, any negative number from -infinity to -2, and union 6 8, that is any number greater than 6. So let's test any value that is less than -2, like -3, into this exact function, and this is going to work. Okay, let me do it like this. Let me test number between -2 and 6, and let's see if it's going to give us x. But to save time, that is it.
Alright, so moving to type of functions. So we have two type of functions. We have the implicit and explicit. So when we talk about implicit function, implicit function, it's a function that they are interlinked. That is that for a normal function, we will say this one is input, this one is output. But when it comes to implicit function, it's a function you cannot specify that this is the input, this is the output. They are interlinked together to the extent that you cannot easily say, let's make one the Sawyer formula. So let's say, for instance, you have something like this: s cube minus 2sy plus 3y square is equal to 7. Let's assume you have something like this. You cannot say you want to make s the Sawyer formula easily. You cannot say you want to make y the Sawyer formula easily. So you cannot say s is my image. You cannot say s is my input. You cannot say s is my output. You cannot say y is my input. You cannot say y is my output, because they are interlinked together. It's not something that is easy for you to change the Sawyer formula. So this kind of function is called implicit function. So when now come to explicit function, is the one that you can easily say that this is my input, this is my output, like something like y is equal to s squared plus 2x minus 1. you can easily say that this is my output. Whenever I put a particular value of x here, I'm going to get a corresponding value of y. So this is an explicit function. They does not these two functions, they are not interlinked together to the sense that you cannot easily say that this is my output, this is my input. So that is the main difference between implicit and explicit function. So mainly, if you want to write implicit function, we used to write it as f of x comma y, where x and y are the two variables there. So if you want to write this, you can write f of x comma y is equal to x cubed minus 2xy plus 3y squared. So with this now, this is telling me that when I put a particular value of x and a particular value of y, I'm going to get a particular output which I call f of x comma y. So if I want to pronounce this, I will say function of x and y. If I want to pronounce it very well, I will say that if I input x and y, the output of x and y. So function is simply like something relating to output. So if you say y is equal to x squared plus 2x minus 1, this is your input. This is what you are going to get, your output. So this is your input. So you say function of your input. Instead of writing y, you can still say function of your input is equal to x squared plus 2x minus 1. If I want to pronounce it, I will say that if I plant x, what I'm going to have first is f of x. So this is my output, this is my input. So I will say that the output of x is this. Do you get? So that is just what this function is telling me. So if I now have f of x plus 1 is equal to x squared plus 2x plus minus 1, that is telling me that the output of x plus 1 is this. Do you get my point at all? That means that if I plant x plus 1, this is what I'm going to harvest. Or if I input x plus 1, this is what I'm going to harvest. So if I say function of 3, that is, if I plant 3, this is what I'm going to get. Do you get my point? So let's now assume that my f of x is equal to x squared plus 2x minus 1. So if I'm asked to find function of 3, that is that when I plant x, I get this. So if I now plant 3, what will I get? So definitely when I have x here, I have x squared plus 2x minus 1. So when I have 3, definitely I will have 3 squared. I'm just changing my input to get a corresponding output. So it's simply 3 squared plus 2 times 3 minus 1. So 3 squared is 9, 2 times 3 is 6 minus 1. 9 minus 1 is 8, 8 plus 6, that is 14. So my corresponding output for this function is 14. So I can say that my f of 3 is equal to 14. So the question says that we should find f of 1 comma minus 1 if f of x is this. That is that when we input corresponding value of x and y into this function, this is our output. So we are now asked that what of if you input 1 comma minus 1, that is your x is 1 at this case and your y is minus 1. So you are inputting x to be 1 and y to be minus 1. So what will be your output? So you know f of x is this. So f of 1 comma minus 1 would give you your value when you put x to be 1 and y to be minus 1. So that will be 5 into bracket 1 squared. My y is minus 1 minus my x is 1, so that will be 1 squared. Okay, sorry, my x is just x multiplied by y cube. My y is minus 1, so that is minus 1 raised by 3 plus 2. My x is 1 minus 3 minus 3y. My y is minus 1 and then minus 1. So with this now, when you say 1 square, 1 times 1, that is 1. Times this 5 will give me 5. 5 times minus 1 is going to give me minus 5. So this minus 1 times 1 cube. 1 cube is 1 times minus 1. 1 cube is minus 1 times minus 1 times minus 1. That is minus 1. Times this minus 1 will give me plus 1. Alright, so 2 times 1 will give me 2. And then minus times minus will give me plus. Then 3 times 1 will give me 3. So and then with this minus 1, this is it. So minus 5 plus 1. Okay, let me do it like this to make it easier. 6, let me add the positive together and I'll also add the negative together. So 1 plus 2 plus 3, 1 plus 2, 3, 3 plus 3, that is 6. Minus 5 minus 1. Minus 5 minus 1 will give me minus 6. So the answer is 6 minus 6, which is going to give me 0.